Okay, hello everyone. Today we're looking at quadratic functions in standard form. And how do we graph them if we get them in standard form? Again, today's objective, graph a quadratic function in standard form. Remember, standard form looks like this, ax squared plus bx plus c. We've seen it before. And earlier in this week, we looked at vertex form. It looks like this. The a is the same, but in this case, the h and the k show you the vertex. In today's essential question, how do we find the vertex and graph a quadratic in standard form? Again, remember when a quadratic is in vertex form, it was pretty easy to find the vertex and graph the quadratic function because the h and k are readily displayed there. And the vertex is hk. All right, the a again indicates kind of a stretch or a compression. The h is the horizontal translation. The k is the vertical translation, up and down. Right? It was pretty easy to find the vertex if it's in vertex form. And then you can graph it. You need to find the vertex in order to graph the quadratic. But now we're going to look at standard form. Remember, standard form looks like this. It doesn't readily display the vertex for us. We have to find it. Now there's a formula for finding the x-coordinate of the vertex, which is the h. All right, it's negative b over 2a. You use the b and the a from the standard form equation. All right, negative b over 2a gives you the x-coordinate of the vertex. Then you can plug it back into the original equation, whatever the value of x is, and find what the value of y is then at the vertex. Again, remember, h also identifies the axis of symmetry as well. So the axis of symmetry is also negative b over 2a when a quadratic is in standard form. In the x-coordinate, h, the x-coordinate of the vertex, once you find it, just plug h in where x is. Again, h is some number. That's how you find k, the y-coordinate of the vertex. Plug it back into the original equation, and you'll be able to find the y-coordinate of the vertex, or k. Again, standard form. Another bit of information that standard form gives us is the y-intercept is readily available. It's c. Where it crosses the y-axis, it's c. All right? That's one thing the standard form gives you right away, the y-intercept. Because when x is 0, y is c. And x is 0 where it crosses the y-axis. All right, so that's another bit of information that we can get from the standard form, just by looking at it. No calculation needed. Again, we can use Desmos. There is a link in our Schoology page here today that can take you to something like this. And you can just put in the A, B, and C and look and see where the vertex is. Of course, you can calculate it. An example here. Here's a quadratic in vertex form, in standard form. 2x squared plus 8x minus 1. Now right away we can look at it and say, well, negative 1 is where it crosses the y-axis, right there. So you can actually plot that point right now, 0, negative 1. But you need to find the vertex. All right, use the formula negative b over 2a. Again, b here is 8, and a is 2. So 2 times 2 is 4, so 8 over 4 is 2, and it's negative. So the x-coordinate of the vertex, or h, is negative 2. Take negative 2 and plug it back into the original equation to find what y is. All right? Again, the y-coordinate of the vertex is k. Put the -2 right here. So it's -2 squared plus 8 times -2. Again, minus the 1. Right, you get -9. So the vertex HK is at -2, -9. And another example, this one's upside down. And you can quickly find the y-intercept is -5. You could plot it right away and say, okay, that point. And you have to find the h. All right, the x-coordinate of the vertex is -b over 2a. Just memorize that. And b here is -6. And a here is -3. You see how I put those in there? And still in front there's still a negative right there in front. That's negative right there. All right, so watch your signs. All right, again, 3 times 2 is 6. It's negative. -6 over -6 is 1. That negative right there is still there. So it's -1. All right, take -1 and put it back into the original equation where x is. All right, which is what I do right here. So it's -3 times -1 squared. All right, -6 times -1, and then subtract 5. All right, I got -2. So the vertex is at -1, -2, and there it is. All right, because the last thing I just want to talk about these types of transformations. We've looked at them, but we haven't really talked exactly about these particular words. You're going to need this for, I think it's the homework check. You know, when a is negative, again, we talked about the graph flips over, flips upside down. That's called a reflection. It's a type of transformation. It's reflected, right, through the x-axis. All right, when the vertex of the graph, when it's moved from the origin, that's what the HK does. It moves it around. That's called a translation. Okay? It moves the graph off the origin, the vertex off the origin. That's called a translation. And you'll remember when a does not equal 1, it could be a half, or it could be 2 or 3 or 4. The graph is narrower or wider. So it's either a stretch or a compression. Okay? Those are types of transformations. And you learn more about those when you get into geometry. Okay, guys, please complete the homework check. And this is what the homework check looks like. Thanks. We'll see you tomorrow.